Okay, awesome. Let's get started. Welcome everyone to another CPTC meeting. Just a reminder, we have this meeting every Tuesday at 6:30 p.m., but we usually start at 6:35 just to let people sort of come in who are a little bit late. This meeting, we're going to be going over the Oauth top 10. So it's going to be a lot of going into some web hacking and sort of the introductory to that kind of stuff. So this is going to be more of an introductory kind of meeting. So it's going to be useful for people who are don't know a lot about web hacking and want to learn about the very basic concepts. So some things to know. I mentioned this pretty much at every meeting, but any topics that you want to learn this semester or potentially teach about in a future meeting yourself, you can put in this Google Sheet, which is also in the Slack and the Discord as well. That's where you can find the link. And also just make sure you guys join the Discord and the Slack, obviously, so you can get all the slides and the videos and all that stuff. And then again, for recordings of last semester's lectures and also past meetings from this semester, I have a link there. Again, it's going to be in the Slack and Discord, but it's also on the UFSit's YouTube channel. So if you just go to YouTube and just type in UFSit, I think it's going to be one of the first ones. And there's an entire playlist called, I think, Red Team Meetings. And you can just basically there's probably 10 or so videos on there right now. You guys can just go through them if you've missed any meetings from either this semester or last semester. This is something that I mentioned, I guess, at every meeting, but again, for this meeting specifically, you guys are going to need some sort of, actually, now that I think about it, you're not going to need a Linux VM, but it might be helpful to have a Linux VM. Or not even just VMware, any sort of Linux device. But if not, actually you're okay for this meeting. But it's good if you don't have one to get one for future meetings, because there's going to be a time in future meetings where we are going to be using a Linux machine, and you guys are going to have one. So if you don't, if you don't know how to get one, you can reach out to me, and I can walk you through setting up a Kali instance. If you do know how to set one up, that's great. Just set one up yourself. And then another thing, make sure you guys make an account on TryHackMe and HackTheBox. Those are the two main sites we use for most of our learning. This meeting, we're going to be using TryHackMe again. So make sure you guys have an account on TryHackMe. And then HackTheBox, you guys can make it, at a future time, because in a future meeting, we're probably doing HackTheBox as well. So what we're going to be doing today is we're going to be learning about the Oauth top 10, and then we're going to be doing a TryHackMe room about the Oauth top 10. So what is the Oauth top 10? I actually don't know what it stands for. Probably Google it, but people just call it the Oauth. It basically represents the 10 most critical and common security vulnerabilities that exist in web applications. The list is updated every few years or so, but it's not updated for the most part. A lot of the main ones that are in this list here have been here for a very long time, just because they've remained the most critical and common security vulnerabilities in web applications. That's essentially what the Oauth top 10 is. It's just basically an up-to-date list of the most common vulnerabilities that you'll find when doing a pen test on a web application. So basically, it's the 10 most common things that you're probably going to want to be looking for if you're pen testing a web app, because obviously it's going to be either the most critical or it's going to be the most likely that the vulnerability is going to exist in that web app. So in this list here, you'll see that some of them are starred. The ones that are starred, those are the ones that we're going to be going into more deep this meeting, just because I don't have time to go through all 10 of them. So the three that you have started here, injection, broken authentication, XSS, are the ones that I'm going to dive into a bit more, and we're also going to do the challenges for on TryHackMe. If people really like and want to know more about the other top 10, then again, I can schedule a future meeting where we can go into working on the other ones. But just to run down the list here, we have injection, broken authentication, sensitive data exposure, XML, external entities or XXE, broken access control, security misconfiguration, cross-site scripting or XSS, insecure deserialization, using components with known vulnerabilities, and insufficient logging and monitoring. So let's get into the first one we're going to learn about today, which is injection. So injection vulnerabilities occur essentially when a user is able to provide an input to a web application, and then that web application interprets the data in a way that wasn't intended by the owner of the web app. That's a very vague and broad way of thinking about it, but that's essentially what injection is. Essentially, you give data to a web application, and it interpreted in such a way that wasn't intended by the web application owner. So, and again, it usually leads to some sort of malicious action, such as executing commands, accessing and returning sensitive data, or giving unauthorized access to the user. So some common types are SQL injection, command injection, and LDAP injection. SQL injection might have been one that you guys probably all heard about before. If you haven't, that's okay. But essentially, what SQL injection is SQL is a database language. So it's basically, if you have some sort of database for your web application that stores, like, let's say, usernames and passwords, you're going to retrieve that data using SQL queries, which is a language to retrieve data from the database. If I have a login form, for example, that's asking for a username and a password, if the web application is not properly secured, I can inject SQL queries into the form, the user form, let's say, as a username, right? Instead of putting in like an actual username, I'll inject an SQL query that'll maybe potentially like dump the entire database. So instead of putting like a username John, I can put in, retrieve everything from the database, and it'll just dump everything. Exactly what Nicholas Fox is saying. Yeah, you can do select all from passwords and like basically dump all the passwords. So that's a form of injection. And SQL injection, up until maybe a few years ago, was one of the most common vulnerabilities that you'd see on the internet when it came to web applications that are using SQL. Nowadays, it's a bit harder to find because it's pretty easy now to secure SQL. And if you're not, then you're doing something really wrong. But it's still a good one to know. So actually, before we get into that one, let's just jump into the challenge. So if everyone can log in to try hack me, and then I'll show you how to get to this box. If you just go like learn all rooms, and then if you just do a search for whenever this loads. Oh, wait, can you guys see this right now?
Yeah.
Okay, cool. So you're going to do a search for Oauth, and then it should just be this one here. And then you basically just want to, there's going to be a join button once you click in here, and you click join. I'm already joined because I have been working on the box for a bit. Yeah, you basically want to join it. And then the first one here is going to be injection down here. Let's check out the introduction, actually. Let's see if there's any useful information. That was basically everything I was saying. Okay, yeah, so for these, for this room, you're going to need to have access to the actual VPN network that TryHackMe has set up. So to do that, I'm going to show you right here. So you guys might want to, if you guys haven't used TryHackMe before, it's probably good to pay attention here. If you go to dashboard, I believe, or actually maybe it's other messages. Okay, actually this might be slash. Oh yeah, just go to tryhackme.com/access, and it'll take you to something like this. And then what you want to do from here is click the region that you're closest to. I'm in Gainesville right now, so I'm doing US East Regular 1 because that's the closest to me. But depending on where you are, you're going to want to choose the region that's closest to you, and then download that configuration file that it's asking you to download. I already have mine downloaded, so I'm not going to, but you're going to want to download that, and it's going to be a file with a .ovpn extension. So I think it's like your username .ovpn. Once you download that, you're going to want to open up a terminal. And this is why I'm saying Linux would be useful to have right now. And you basically want to have, the first thing you want to make sure is that you have OpenVPN installed. So you can check by like auto tabbing if it is. So I already have it installed, but if you don't have it installed, you want to do sudo apt install OpenVPN, just like that. Then hit enter. It's going to ask you for the password. And then it's going to basically install it for you. So that's how you install OpenVPN. Does anyone not have OpenVPN installed or needs help installing OpenVPN, or needs help getting to this access site and downloading the configuration file? Okay. Okay, cool. So in that case, then once you have your OVPN file downloaded and you have OpenVPN installed, use download OpenVPN on that button. Yeah, so you want to download it you're downloading the configuration file here from this green button here, and then you want to install the OpenVPN software using sudo apt install OpenVPN.
Oh, you're only sharing your browser right now.
Oh, okay, my bad. Let me see. New share. Thank you for letting me know. Okay, can you see my terminal now?
Yeah.
Okay, cool. Yeah. So sorry, this is the command you guys are going to want to type to install OpenVPN software. In the terminal, sudo apt install OpenVPN. And then you hit enter and it'll install it for you. So once you have that installed, okay, so yeah, for Windows, what you're going to want to do is go on the internet and just type in OpenVPN Windows download, and you just want to download OpenVPN. It's free, very popular. Yeah, and you just want to look for the Windows 64-bit or 32-bit installer and just install OpenVPN like that. And then once you have that installed, then you can just start it up, and then you're going to give it the configuration file that you downloaded from Try Hacking from here, from this link. So for people who are using Linux, once you have OpenVPN installed and you have the configuration file downloaded, you're going to want to go to that configuration file that you downloaded. It's going to be in your downloads directory. So if you just do cd into downloads, and then you want to do then the command OpenVPN, and then the name, or you want to do, sorry, sudo OpenVPN, and then the name of the configuration file that you downloaded. So it's going to be like, your username.ovpn, whatever your username is, whatever the file name was. Then you're going to hit enter, and then you're going to see a bunch of text, and then it should connect. And you want to leave that open. So I'll show you by doing it on mine. Mine's in a different directory. So mine's here. Mine is called johnwoodman.ovpn. So I'm going to do sudo openvpn johnwoodman.ovpn. I'm going to hit enter. You're going to see a bunch of text. When you see this here, initialization sequence completed, that means you're good. It means you're connected. And you don't want to close this terminal. You want to leave it open for the rest of the meeting, because that allows you, that keeps your connection to TryHackMe's VPN network. That might have been a bit quick or confusing. Is anyone like stuck on a certain part that I can help you through?
I have my Linux subsystem, Windows subsystem, but I don't have access to my downloads folder, so I need to transfer the.
Okay, yeah. So actually, to access it from in the Windows subsystem, you're gonna want to do it's gonna be /mnt/c/your username, whatever your Windows username is, and then /downloads, and then it should be in there.
Oh, sweet. Okay.
Yeah. So yeah, whatever your username was, and then /downloads. So is anyone having any issues, or anyone who isn't connected to the OVPN network?
It says there's no such file or directory.
Oh, really? Let me see. So you're doing /mnt/ I think it's c/ whatever your username is /download/ then the OVPN file.
Do you have to change your directory to that?
You should.
Yeah, that's
so if you do,
that's exactly what I did.
Oh, okay. Yeah. So if you do like sudo OpenVPN, and then that username /downloads /username.ovpn, that didn't work for you.
I didn't do the OpenVPN command.
Yeah. Try doing like this command here. Obviously, replacing the username with yours. Yours acting due to a fatal error. Oh, are you using Windows or Linux, Jason? Linux. Is it saying like, is there like an exact specific error, or is it just saying fatal? Just fatal, huh? And you're doing a sudo OpenVPN, not just OpenVPN? That's really strange that it's giving you fatal. Let me Google that actually. Linux Openvpn fatal error. So something like this, exiting due to fatal error. That's for a different. Are you still getting the error, Jason? Okay, cool. Awesome.
Do you know how to enable SSH on the Ubuntu?
Yeah, like just like so you can SH into it.
Yeah, so I can SFTP the file over.
Oh yeah, it's gonna be sudo service sshd start. Let me make sure that's right. Okay, yeah, so sudo service sshd start should work.
All right, thanks.
Yeah, no problem. I guess let's just, so is everyone able to like, can you raise your hand in like the Zoom thing if you are connected to the Openvpn? If you're like, you're all set basically. Okay, cool. I have a few.
I'll get there in a second. I just need to move.
Yeah, no
over.
worries. Take your time. Okay. Okay, finish downloading. Okay, awesome. Cool. Just have a few people. And if you guys are having any issues, you guys can just, you speak up, put anything in the chat, and I'll be glad to help out. Or if you're just following along, you don't want to dig into that's okay too.
Okay. Shoot. Yeah, it's still saying connection refused, and it says it's running on my Linux machine though.
When you run the OpenVPN, it's saying connection refused?
No, when I try to SFTP from my Windows PowerShell.
You're trying to SFTP to the Windows subsystem?
Yeah, to transfer the file over.
That might be a firewall issue, but you might not even have to do SFTP. If you go into like the Windows subsystem for Linux terminal, if you do like, can you CD into like MNTC and then your username? Can you do that or no? Does it not let you?
Let's see. Oh yeah, it's let me do that.
Okay, yeah. So then once you do that, try to go into the downloads folder within that. And then if you want to copy that over to like, your home directory in
Oh, I see
WSL.
what the problem was. It's users and then I didn't put users.
Oh, gotcha.
Yeah. All right, sweet. All right, I got it.
Awesome. All right. So if anyone else is still not connected, let me know and I can try to help you either in the chat or speaking up, whatever you want to do. But if not, then we'll go ahead and get started with the room. So to get to the room, like I was saying before, you go to learn all rooms. And then once this loads, just do a search for Oawsp. And that's the room there. Oawsp top 10 is the name. And then you guys can go through, we'll go through the introduction here, which is everything I've talked about. This is no answer, you can question done, and it'll complete it for you. Accessing machine, same thing, basically what I just said. We're all connected now, so we all should be good there. And now let's get into injection. So this is basically everything I was recapping before. So this is, if you guys want to read more in depth, you can. I feel free to after the meeting. We're going to go ahead and move on because I explained for the most part most of what injection is. And then this is OS command injection specifically, which is what this challenge is going to entail. So we can read about this. So command injection occurs when server-side code, like PHP, for example, in a web app makes a system call on a host machine, basically executing a system level command from the web app's perspective. So a web app vulnerability that allows an attacker to take advantage of that made system call to execute operating system commands on the server. Sometimes it won't always end some malicious, like who am I? Yeah. So at the end of the like I was saying here, the main thing that when you're hacking a website and you have command injection like this, the main thing you're trying to do is spawn a reverse shell. What basically that means is that you want to be able to execute commands on the web application in such a way that it'll call back to your malicious server and allow you to basically drop into a shell on that web application server and then execute all the commands you want, basically, however long you want. So this is like an example. NCSE bin bash is all that's needed, and then you can own the server, for example. So yeah, once the attacker has gained foothold, they can do enumeration and start looking for ways to pivot around, et cetera, et cetera. So now let's get into the actual challenge. So we're going to want to deploy the machine, but it's just by clicking the deploy button here. And then it's going to take, it takes about a minute or so for it to actually, for the IP to show up. But for now, we can start reading this stuff. So blind command injection occurs when the system command made to the server does not return the response to the user in the HTML document. So that would be in the case of like if you had, if you're like for, let's say, a login page, for some reason, it was allowing you to do command injection. A lot of the time, it's not going to just return the output of the commands directly to you. So it's harder in that case to know if you actually have command injection, because if you type in like who am I, right? If you inject that command, it's not going to return out any output to you. So that's what blind command injection is, where you don't receive output directly, and so you have to figure out other ways to know that you have it. One example would be like injecting a sleep command. So like sleep for like 10 seconds, and then you'll know that works if the web application is taking 10 seconds to actually load and respond to you. Then you know you have command injection. So those are ways that you have to do in order to actually find blind command injections, because it won't just return the output. So here's an example here of some vulnerable code. So this is PHP. So it's basically checking if a parameter in the URL has the key command string, if that value is set in the URL parameter. And if so, it's going to set it to a variable called command string. And then it's going to run it, it's going to pass it to this function called pass through. Now what pass through is basically, it's whatever string is in here is going to get executed on the web server, basically as if you were like in the terminal running a Linux command. So let me actually look up PHP system commands, because there's a list of them. So here. This will ever load. Let's see. Okay, yeah, so these ones here. So this is a list of PHP functions that will run commands directly on the Linux terminal of that web application, of that web app. So there's exec, there's pass through, like I was saying before, system, shell exec, popen, proc open, and pcntl exec. So if you're looking through like someone's web application code and you see any one of these functions, you're going to want to look deeper into that because there's potentially a way to do command injection there. So in this case, it was the pass-through function. So this is taking in direct user input from the internet and then executing it on the web application server. This is really dangerous code. And this basically just recaps what I was saying, checks if it's set, then says it's this variable, then puts it through the pass-through. So ways to detect active command injection. We know that active command injection occurs when you see the response from syscall. In the above code, the function pass-through is actually what's doing all the work here, like we were saying before. It's passing the response directly to the document. So commands to try. So now if you guys have the box open, it'll give you the IP address here. So you're going to want to go to this link here. If you just do like a right click, open a new tab, it's going to show this thing here, this sort of evil shell website. And so what this allows us to do is that we can execute commands and then it'll run directly on the web application server. So if I do like who am I, for example, we get user www-data. So this is being run on the web server. This isn't being run on my local machine or anything. This is being run on the remote server that's hosting this website because this website is hosting this code here. So the command string in this case is who am I, like I just typed, and it's getting passed into pass-through, which is getting executed, and then it's just returning the output. Is anyone confused? Is anyone not seeing this website? Is anyone not able to enter commands here?
Yeah, mine, it says the site can't be reached, took too long to respond.
Okay, are you doing HTTP or HTTPS? If you go to the top, make sure it's HTTP because it won't work if it's HTTPS.
Okay.
That work for you?
No, yeah, it's still spinning.
Oh, okay. Are you able to ping this IP address from like your from your Windows PowerShell terminal?
Let me check. No, I'm not.
Okay, so and your Openvpn thing is still running?
Yeah. Is it because it's running in the Linux subsystem?
I think that's what it is. So you're probably gonna have to install Openvpn for Windows. So if you just Google
Okay.
Openvpn Windows download, and then download the MSI and install it, then you can run it from Windows, and you should be able to access it from there.
Gotcha.
Yeah. Let me know if you run into issues setting that up. It shouldn't be too hard. But okay, so now let's get into the challenges here. So if you guys are you guys are familiar with Linux, then these questions here below should be pretty easy for you to answer for the most part. If you're not though, I'll help you through it. So I'll give you guys maybe like 5 minutes or so to try to work through them on your own. And just, if you don't know Linux stuff, try Googling some of the stuff for like some basic Linux commands to look for stuff. And then after the 5 minutes, then I'll just go through the questions, and then I'll explain each one. And if you guys have any issues right now, even connecting or anything like that, let me know right now and I can help. Yeah, if you're doing it on Windows, that's actually okay because the commands being run here are all Linux commands. So like I don't know, uname-a, for example, like that works. Like these are all like, for example, this is a Linux command here, as you can see. You can ping the IP but cannot access the web page. Are you doing HTTP? Make sure at the top here on the URL that you do HTTP:// and not HTTP. Okay, you double check that. And it's the right IP, right? Like yours might be different from the one from mine. It shouldn't be this exact one. It should be whatever yours is. Okay. Huh. Still, that's very strange. And your OpenVPN, you can ping it. That's very strange. Try terminating it with this button here and then deploying it again and then giving it another try. That's strange that you can ping it and you can't access the web page. Yeah, try terminating and deploying it again.
So after I download the OpenVPN and set it up for Windows, do I just run the same thing like OpenVPN in the PowerShell?
So actually with Windows, there's like a little GUI client, I think, for OpenVPN. So if you just like do a search in the search bar for OpenVPN, you can start that up and then just select the OVPN file for the configuration and then connect it there. So you won't have to do anything in the terminal for the Windows version.
All right, thanks. I got it.
Awesome. Jason, were you able to get it, or is it still having issues? Okay, cool. And you're using all Linux, right? You're not using any Windows stuff? Linux virtual machine. Okay. And you're accessing the web page from the virtual machine, right? Okay, cool. Just making sure. Give you about another minute or so before I start going into the questions. Were you able to connect, Jason? Huh. And you said you can still ping it, but you can't access the web page. Huh. Would you mind sharing your screen just so I can get a better look? If you're okay with that. Let me see if I can give you permission to. See. Are you able to share your screen? Yeah, it could be a browser thing. If you're using Chrome or Firefox or something. Okay, cool. So yeah, I can see your screen there. So yeah, you're connected, and then okay, I noticed you're pinging it though, you're not getting anything, which is Strange. 10.10. Try doing Control-C on the OpenVPN session you have in that terminal, and then running it again. So yeah, Control-C just to quit it, and then yeah, try running it again. Okay, and then try to ping it again from the other terminal. Oh. 10.10.191.46. I mean, that's all right. Okay, here's what we're gonna try to do. End the OpenVPN session again. Do Control-C on it, and then re-download the OpenVPN configuration file from TryHackMe. So if you go to tryhackme.com/access again, and try to get a, or do instead of doing do regenerate. Try that. Yeah. Okay, and then do download. Yeah. Although it's weird that it shows you're still connected. Okay, you downloaded that. Could you go to your terminal, the OpenVPN terminal, and then can you do PS space AUX? Or here, actually, I'll type in the chat just so it's easier. PS AUX grep VPN. Try if you could type that command. Yeah, PS space X, and then pipe that through grep for OpenVPN. Okay. Yeah, so we have a lie. So here's what I want you to do. I want you to do this command, but instead of ID, put in the number where it says like 2416, 2417, 2516. Do ~9 multiple times with each of those IDs. Oh, sorry. Do probably want to do sudo. Kill, yeah. Okay, yeah, and then do and then do it for the next one, whatever one shows up. Because I think what the issue is that you have a lot of sessions open, and we want to close basically all of them. Yeah, and then just keep going through them. Cool. Awesome. So now the most recent one that you downloaded, the most recent OVPN file that you downloaded, make sure it's that one. You want to do sudo openvpn again, but only on that one. So I guess the one with like parentheses 2 on it. I think you have to escape the 2, so you have to do like \2, I think, before the parentheses, I think, or sorry, \parentheses and then 2. I could be wrong about that actually. Oh, okay, maybe not. And then yeah, try .ovpn, see if that works. Okay, cool. Now try to ping it one more time. Awesome. Okay, now try to go to the website. Okay, it looks like it's working. I think. It might just be really slow. Yeah, the fact that you can see the title thing at the top, which is Evil Shell, means that it is working. It's just the connection's just really slow. Yeah, you just gotta give it a second. Yeah, try closing the other tabs maybe. Oh, okay, there we go. It's still really slow, but at least you have some way to enter commands. Okay, cool. Let's see. I'll go ahead and reshare my screen here. Okay, so that should be probably enough time for the other people. Yeah, no problem, Jason. So I guess I'll start going through the questions here. So first question is, what strange text file is in the website root directory? So if we go here, if we do pwd, which stands for print working directory, we're going to see the exact directory that we're in, which is var www.html. This is the standard directory path for where all the source code for websites are stored. So it makes sense that since we're hacking a website, that the current directory we're in is this directory, because it's the default one for source code. So it's saying here, it's asking us what strange text file is in the website root directory. So I don't want to spoil it, but let's just do ls to list all the files in the current directory. And we see here CSS, which is, everyone knows what CSS is, I would assume. It's like the coloring style stuff for websites. We have evilshell.php, which we know is not unusual because we know that's the code that's running, which is this stuff here. So that's not really unusual. Index.php is not unusual because that's like the standard like index.html, but for PHP files. And then JS, JavaScript, not unusual. However, this guy, drpepper.txt, that is pretty unusual. So that would be the answer for what strange text file is in the website root directory, drpepper.ext. Let's actually cat it to see if there's anything inside of it. Dr. Pepper. For those who don't know, cat just basically outputs the contents of the file. I love Dr. Pepper. Okay, cool. So how many non-root, non-service, non-daemon users are there? So what this means is if we do a cat, again, to show the output of the file, we do cat etc passwd, this is going to output the contents of the etc passwd file. What this file is a list of all users on this web server. Now, there's a lot here, and it might seem strange there's a lot, but actually, like 99% of them, most of the time, are all just service-related accounts. So these are like users that are required to be on the machine for certain services to run. For example, www-data is a user that we need in order to run web applications. And that's why actually we are, if we do who am I, we are the www-data user, because that's the user that's running this web application. So it's not like a standard user. You can't like log in like through SSH with www-data because it's not like a normal user. It's not like, user Bob or Tony or Joe. It's specifically a service or daemon user. So it's asking us how many non-root, non-service, and non-daemon users are there. So we're looking for how many normal users there are. That would be like, our Joe or Bob or etc. What was the command I didn't put it before? The cat etc passwd. Is that the one? Sorry, Darren, I just saw that. I was a bit late to that. I'm not sure which. Before ls. Let me see. Was it the uname? Was it this one? I don't actually remember. Oh, was it? Oh, pwd it might have been for print working directory to get this guy. Okay, yeah. PWD stands for print working directory. It just outputs the current like directory path that you're in. So we're currently inside of var www.html. Yeah, no worries. Okay, yeah. So we're looking for non-root, non-service, non-daemon users. So we're looking for like, our normal, super normal users like, Joe, Bob, Tony, etc. Like those actual normal users. So there's a couple ways we can do it. One would be, and this is something to know, is that all normal users will have a directory with their name inside of the /home directory. So any like when we did cat etc password, these users, these service users, they're not going to have a directory in the /home folder because they're not normal users. Only normal users will have that. So if we were to do ls on /home directory to see what folders are in there, it's empty, meaning there are no normal users in there. So that's why the answer here is 0. There are currently no non-root, non-service, there's no like normal users on this machine. And that's, you confirm that because if we do ls/home, we can do ls/la to show like everything. We can see there's no user that exists in this directory. Therefore, there's no normal users. Another way you could have done it, like if you look at the etc password, you could figure out that there isn't any, but this is like crazy to read. Like, why would you spend your time reading this when you can literally just do ls on the /home directory? If there was a normal user, let's say a normal user named like Bob, if we did ls/home, when we do that, there would be a folder here named Bob. And that's how we know there's a normal user on here. That's why the answer is 0. If anyone's confused by like the stuff that I'm going over right now, feel free to speak up, anything in the chat, and I'll try to better explain it or answer any questions. So what user is this app running as? We had answered this before. If you run who am I to get the current user, it's www-data. Each user is separated in different files, right? Yeah, so each normal user will have its own folder with all of its own files. So like I was saying before, if we do like ls/home, if there were like, a user like Bob, Joe, Tommy, inside the home directory, there would be 3 folders named Bob, Joe, and Tommy. And that's where that user would put all of their own personal files and stuff. Yeah, so for this question here, what is the user is app running as is www-data, because we just ran who am I to see what user we are, and we are www-data. Cool. The next question, what is the user's shell set as? Now this one's a little bit harder to understand, but we can actually find the answer inside of the etc password. So the etc password defines all of the users, including service-related users, for the machine, right? So normal users and service and daemon users. So we can see here there's a format to it. So it looks really messy because of the way it's outputting in a website. But if we go to this is my local Linux terminal, right? If I do cat etc passwd, this is what mine looks like. So it's a little bit easier to read because it actually is line breaks and you can actually like go through it. But this is the format. You'll notice there's like a format for each one. So there's the name of the user, right, which is the first one. Then there's separated by each, I guess, value or key is separated by a colon. So we have the first one is the name for each in the first one. Then next is like, I don't even know, it's like almost all X. You can Google like the passwd format and it'll explain each one. But the ones that we care about is really just the username. And then there's also here is like, this is, I believe, the group ID, or sorry, the user ID and then the group ID. So root is 00. And then like bin, for example, is 22. Let's see if I can find mine. Yeah, mine is 1000, 1000, etc. And then again, the other ones don't really matter so much. The ones that we care about the most here is this last one here, which specifies the shell access that user has or is allowed to have. So root, for example, is allowed to have bin bash, which means that they can have a bash shell, right? The root user can have a bash shell. However, you'll notice here for all of these service ones, they all have like user sbin no login, which basically means that you're telling the Ubuntu, this is a service user, so they should not be allowed to log in like a normal user would. So like all these are service no login because you don't want a service account to be able to log in because they're a service, they're not an actual person. They shouldn't be able to just log in. If we go to John though, which is my username right here, I have bin bash because I am a normal user, so I should be allowed to have a normal shell. But all these service related ones should all have user sbin no login, or bin false is another way to put it as well. So that's what that last one means. And that's what this question is asking us is, what is user shell set as? So what is www-data shell set as, which we can read here. If we just do like a control F for www-data, we see here that's the name of the user. This is group user 33, group 33. And then if we go to all the way over here, we can see it's user sbin no login, which is expected because it's a service account. It should not be able to just log in as a normal user. So that would be the answer then. It's going to be user sbin no login. Is there any questions on that one? Because I understand that one could probably be a little bit confusing, especially if you've never seen like the passwd file before.
Yeah, I got a question.
Mhm.
What does it mean by the Daemon user?
So the Daemon user, actually, let's even do a Google, because I don't really, like, I use Linux, but like I don't know every single part of it. So let's do Linux Daemon user. I believe that's in charge of like starting all the services and stuff. Let's see. The Daemon user group ID was used as an unprivileged user for daemons to execute under in order to limit access to the machine. That's not a great explanation. Let's see. Specifically for Ubuntu. Turns other processes in. Oh, okay. So what that user is in charge of is, so the difference between a daemon and a service is that a daemon is like constantly running in the background, whereas a service will like stop out on a reboot, right? And you have to start it up again. A daemon allows it to be constantly running in the background even after reboots. And then the daemon user is in charge of managing all those daemons, essentially. So it's in charge of turning services, I guess you can say, into daemons. So it's being run after reboot. That's essentially what a daemon is. And so that's a user that you'll see on pretty much all Etsy PassWD files is a daemon user, because it's in charge of like, all the services that are running through reboots.
Gotcha.
Yeah.
Thanks.
No problem. Okay, so let's go to the next question. What version of Ubuntu is running? So this is something that you could just like basically Google of like, Ubuntu command line get version, right? And then we can see here, type the command lsb_release-a. So let's give that a go. Score release-a. And we can see here, Ubuntu 18.04.4 is the version of Ubuntu. And then you can see here, that's the answer. So a lot of these are basically like Linux, like command line stuff. So if like stuff that you would either already know because you're familiar with Linux command line, and if not, it's a pretty simple Google search to be able to find it. So print out the MOTD. What favorite badges is shown? So MOTD stands for message of the day. For those who have used SSH before to SSH into like a remote Linux machine, you'll notice that like when you SSH in, you'll get like a bunch of messages. Like here, I'll give an example. I'll SSH into another machine here. Now notice when I SSH into this, I get all of these messages here, like welcome to Ubuntu, documentation. This is technically called the MOTD, or the message of the day, or at least part of it is. So this is essentially what they're talking about by MOTD. And what we're looking for here is print out the MOTD, what favorite badge is shown. So we're trying to look for that in the evil shell here. So that, again, this is just you're basically Googling to find where that message is stored. So if we go to Google here, we look up Ubuntu MOTD file location. Let's click on the first one. So here it's inside the directory ls etc update-motd.d. So let's go over here and let's do ls on /etc/update-motd.d, see what files we have in there. And so you will have a header file, a help text, a landscape, sysinfo, MOTD news, ESM, live patch, a whole bunch of like messages that get shown when you're when you SSH into a box. If we go back here, the welcome to Ubuntu one is really the message of the day one, because that's like, it's at the very top. It's the message that you're trying to tell the person who's SSHing into the box. The rest here is like related system information stuff. So that would be stored in like these kind of stuff here, like updates available, etc. So we're looking for the one at the very top. So that's probably gonna be the header file. So 00-header. So if we do cat /etc/update -mo, update-motd.d/00-header to output the contents of that, we get basically this whole long thing, which is basically just the welcome message. But if you look at the very bottom, Dr. Pepper makes the world's tastes better, that would be the message that gets displayed when you SSH into this box. And so therefore, that is the answer for this one, Dr. Pepper. Does anyone have any questions with this one? This one, again, a little bit confusing, but it's good to know, I guess, the MOTD is basically just the message gets shown when you SSH into a box. Okay, cool. And that was the last one. So does anyone have any questions about command injection or any sort of injection in general as it relates to web applications? Okay, cool. So if not, then we're going to go ahead and go to the next vulnerability. So make sure you guys terminate your boxes because we're going to be deploying another one for the next challenge. Let's just make sure you terminate that for now. We can go ahead and close this guy. So now we talked about injection. Let's talk about broken authentication. So broken authentication is usually due to improper implementation of web applicants' authentication mechanism, which can lead to compromising sensitive data or sensitive authentication related data, such as passwords, usernames, session cookies, etc. And then that can be used to gain access to that user's account. So it's best probably just to jump into the try hacking for that one. So if we go here, so let's see, if an hacker is able to find flaws in we can then use some common flaws in authentication might include, so some examples that would be like brute force attacks, weak credentials, or weak session cookies. So brute force attacks are pretty self-explanatory, allowing you to basically like brute force the username or the password to be able to log in. Another one, using weak credentials, is again another pretty obvious one, in the fact that like if a user has, you know, their password is like 1234 and it's super easy to guess, then that's a flaw in the actual web application, because the web application should be making sure that when users create an account, that the password should be of a certain length and of a certain complexity. And then there's weak session cookies, which is similar to weak credentials in the fact that if you're able to basically brute force and guess the cookie of a user, then you can impersonate them. So like if a normal user logs into a website, right, they receive a cookie. Usually the cookie is supposed to be a very long and complex string. However, let's say they're given a cookie and it's just like the number 3, right? Then if I can basically just start guessing cookies, if I just do like, 1, 2, and then I try 3, then I just guessed their cookie correctly. I basically now have access to their site. I mean, I have access as that user to the site. I basically impersonated that user. That's what a weak session cookie means. So let's just get into the practical part. So I guess something else I should mention. So it's not, broken authentication is not just brute forcing or guessing weak credentials, guessing session cookies. It's basically anything related to authentication that gives you access in a way that is not intended. And we're going to see one basically right here. So another one would be like, let's say you have you can register a user on a website, right? And you give it a username. But let's say that website isn't checking if the username already exists or isn't checking it properly. So let's say there's an account that's already exists on the website that's called John. But let's say I decide to create an account and I want to call it John 2. If the website isn't checking for an existing user, it might just allow me to create an account called John. And then if I log in, if they set it up incorrectly, I may now have access to that other John's account just because we have the same username. And just because the web application didn't check that the username already existed. So that's an example of broken authentication. So we'll go through this example, and it basically is a similar idea. So we're going to go ahead and deploy this box. It's going to take another minute or so. So for this example, we're looking at a logic flaw within the authentication mechanism. A lot of times what happens is that developers forget to sanitize the input using a password given by the user in the code of the application, which can make them vulnerable to attacks like SQL injection. However, we're going to focus on a vulnerability that happens because of a developer's mistake, because it's very easy to exploit re-registration of an existing user, which is what I was just talking about. So let's say there's an existing user with the name admin, and now we want to get access to their account. So we try to re-register that username, but with a slight modification. In this case, they just added a space just before the username. And it basically allows them then to create that account, and then we can log in with admin and get access to their account. So once this finishes here, we'll be able to do the same exact thing with the username Darren. And actually, I'll give you guys probably about probably 2 minutes, because this one's actually fairly easy. I'll give you guys about like 2 minutes to try to do this machine on your own, and then I'll just go through it, because it basically just tells you what to do. So it's pretty straightforward. Yeah, what is the flag that you found in Darren's account? And just give that a go. All right, so we're going to go ahead and go through this first question here. So let's go to the website. So we have a simple login and a register. Let's just try to log in as Darren right now. So Darren, and then I don't know the password. I'm just going to type in password just to see what works here. Invalid usernames. Okay, so let's try to register, and let's just try to register with just like the normal name Darren, no like spaces or anything. Type in a random email, password, blah, and we try to register it. It's going to tell us this user is already registered. So let's go back here. Now, if we put a space in front of it, one space, and then do Darren, and then do test@gmail.com, and then do blah, you notice it let us. It didn't give us any errors. So now, if I put in Darren, and then I put in the password that I had just set, let's just blah, and then we sign in. Oh, wait, sorry, space Darren, and the password we just set. Boom, it works, and we're able to log in, and now we're logged in as Darren, and we got the flag. So that's like one example of broken authentication, is when they're not properly parsing usernames in a correct way, because you can just put like a simple space in front of it, and then it'll treat it as a new user when you register, but as the same user when you're logging in.
Does it treat it as the same user? Because like space isn't allowed in a username.
Sorry, can you say it again?
Yeah, does it treat it as a new like account? But then when you log in, does it count as Darren because like usernames don't allow a space?
Yeah, so in that, this is something that we have to get the actual source code for. I imagine it's treating it as a different user when you log in, because when I try to do, if I like log out here, if I just try to put in Darren with no spaces and then like a password, it tells me invalid, right? Because so I think it's treating as two separate accounts, but once you log in as the other one, whatever data it's retrieving for that account, it's treating it as the same one. So like if we go here, when it's retrieving like this, for example, it's going to retrieve the other Darrens, not the one with the space. So I think that's where the error is happening. So I think it is technically two separate accounts, but when it's retrieving the data for the account, it's treating it as the same one.
Okay, see, thank you.
So that's something that we'd have to like actually like dig into the source code to figure that out. But based off like the what we're seeing, that's the best guess I could take for that. So the other one is basically the same thing. Now do the same trick and see if you log in as Arthur. So it's basically just the same exact thing. So if we log out, let's just try to log in as Arthur right now and see what happens. It's going to tell us nope. So let's go ahead and register. If I register him without a space, show him again. Password blah. It's going to tell us already exists, so we can't do that. So let's try to put a space in front of him now, and then do Arthur. Put a random email, and then blah again, and it registers it fine, no errors. So now let's try to space Arthur and blah, and then boom, we got the flag there. So it treated it, and it says here logged in as Arthur. You'll notice here that there's no extra space here because it's treating us as the other Arthur. That's how you know. So then that's the flag for that question. Oh, wait, sorry, there's no flag for that one. So that's the same thing. So what is, oh yeah, never mind, it is a flag. So what's flag for Arthur's account? It's just that right there. So yeah, that one was pretty simple and straightforward. It sort of just tells you what to do. But that's the very basics of broken authentication. And there's a lot of ways you can really dig into the different types of broken authentication. Like this is just a very basic example. But if you like, I think if you go to the Oauth website and go to the broken authentication like section, it'll walk you through like so many different methods for like how websites can like mess up, and you can use that to your advantage to like log in as another user essentially. Are there any questions on broken authentication at all? Okay, if not, then we're going to go ahead and go to the last one here, which is going to be XSS. So XSS stands for cross-site scripting, and it's probably the most common vulnerabilities that I've ever seen on the internet, and probably that you'll see. And I think it's something that's lasted for a very long time, and I think it's still going to last for quite a few years down the road, just because of people just don't really understand how to sanitize it. So it occurs when a web application accepts any sort of user input, and it's similar to injection, right? So a website accepts user input, and then a user inputs data that's interpreted in a way that was not intended by the web application. In this case, though, it's being interpreted specifically as JavaScript. So XSS is basically a form of injection, but you're injecting only JavaScript into the web application, and then the web application is interpreting it. So let's say, again, let's say you have a login form, right? It's asking for a username and a password, but instead of entering like, Bob for the username, you enter in JavaScript, and the web application, because they didn't sanitize it properly, actually executes that JavaScript. And that's what XSS is essentially. And then this allows a malicious actor to run JavaScript on a victim's browser, which can lead to stolen session cookies, redirecting to a malicious site, or defacing the web application entirely. And so the main reasons vulnerability exists is due to improper or none at all sanitization of user input, which basically also means not escaping user input. So let's get into the challenge for that, just so we can give you a clear example. So if you scroll down all the way to task 20 here, it's a cross-site scripting one. That's what we're going to do. You can go ahead and hit, or actually make sure to terminate your other box first, and then deploy this one. All right, so while it's waiting to show the IP, we'll go through here. So there are three types of cross-site scripting. There's stored cross-site scripting, reflected, and DOM-based. So stored and reflected are the most common ones. DOM-based is not super common, but we'll still talk about it. Stored XSS is the most dangerous type. It's where basically malicious strings are the XSS that you inject is actually stored on the website's database, like for a non-temporary amount of time, I'll say. So so this happens like when basically user input, let's say you're on like a web forum, for example, and you're like chatting with friends, right? Or you're chatting online, like, I don't know, let's say Reddit, for example. You're on like a Reddit forum and you're chatting with people. When you put in a comment, right, that gets saved on Reddit's servers, right? So that way, you can like go away from the app and then go back, and your comment is still going to be there, right? So other people can still view it. It's stored on Reddit's web server. If I was able to inject JavaScript into that using XSS, that's being stored on Reddit's web server. So essentially, anytime someone visits that specific forum, wherever I commented it, that XSS is going to run on their machine. That's what stored XSS is, essentially, is that like when you inject XSS, but it's stored on the website, so that way when other users visit your XSS wherever you injected it, it'll get run on their browser. So reflected XSS is basically part of the request to the website. So this essentially would be like in the URL. Let's say you have like http example.com/ username is equal to John, right? And that's all in the URL. So like something like this. So let's say example.com/ question mark, whatever, username is equal to John, right? Let's say that's the web request. Let's just do that. So this is the whole URL here. Now let's say you're able, and let's say when you enter this, when you go to that, let's say it displays on the page, hello John, right? For example. And then so basically meaning whatever you place here, it's going to say hello, whatever. So I put Bob here, it's going to say hello, Bob. Let's say if I were to replace this with JavaScript, it's going to then run that JavaScript instead of saying, instead of saying hello, whatever, it's going to say hello, and then it's going to run the script that we give it here. So like if we put like script alert 1, which for those who don't know JavaScript, so the script tags basically means anything in between these tags is JavaScript, and alert 1 just puts a pop-up on the browser, and it's going to just have the number 1. So this is what reflected is, where the XSS is actually in the URL, and not like in the comment section as it would be with like stored XSS. Does that make sense to everyone? I know the difference between those two can be a little bit confusing, but once you sort of like start practicing it, you'll learn to understand the differences. So then DOM-based is, again, not super common, but it stands for Document Object Model, and it's a programming interface for HTML and XML documents. It represents the page so that programs can change the document structure, style, and content. So this basically allows you to basically deface the website in certain ways. And it's like, yeah, that's the main part of it. It's like, it's not a super common one. You don't really have to worry about that one. The two ones you want to focus on is stored and reflected, but just know that DOM-based stands for Document Object Model, and it basically allows you to interface specifically with the HTML source code and basically edit however you want. So here are some common payloads. Like I was saying before, the pop-up ones, which is like script, alert, and then it pops up hello world. You can use document.write, which will edit the HTML of the website, allowing you to deface it entirely. And there's actually some really cool ones, which get a bit more complex, but are really cool, which you have like XSS keyloggers. So if you are able to successfully inject cross-site scripting into a website, you can inject a keylogger into it. So then anyone who like visits that part of the website and it gets injected, you can start basically stealing their keys, whatever they're typing gets sent to you. And another one is cool as a port scanner, basically like whoever, again, the victim that goes to that website, it'll start scanning, do a port scan on like, on machines in that victim's like network. So those ones get a bit more complex, but are still pretty cool. So, and then there's some website you can go to like look at all the other XSS payloads that they have there. So let's get into the challenge. So deploy the VM, done. Navigate to this site here. Let's go ahead, take a look. Let me close this guy. Oh. Move that over. Okay. So we have this guy here, and it says here, click on the reflected XSS tab on the nav bar, saying hello. So actually, I'm going to let you guys work on this one for a few minutes, and then I'll hop in and go through it. But it's basically right here, it explains what we're trying to do. Craft a reflected XSS payload that will cause a pop-up saying hello. So reflected, again, means it's going to be in the up here in the URL. So term from URL, you can notice here. So if I put in here, for example, just as a little hint, I put in John, notice how it puts John there. All right, if I put Bob, It puts Bob there. So this is what reflected access is all about. So now you want to inject your own JavaScript into this. So I'll give you guys a few minutes to work on that. If you guys have any questions, let me know. Okay, so let's go ahead and get into the first one here. So it's asking us to navigate to that, and then craft a reflected access payload that will cause a pop-up saying hello. So like I was saying before, if we can change this value here to whatever we want, it gets reflected here. So let's first do a quick little test and then see if we can inject any HTML. So if I do like B and then test/B, for those who don't know HTML, anything within the B tags makes the text bold. So we'll see here right now it's like just normal text, but if we do this, notice now it's bold. So that's how that's a good way to test without, if you're like doing a pen test on a website or hacking a website and you're testing you're testing for XSS, but you don't want to potentially cause like permanent harm to the website. Doing like simple HTML stuff is a good way to check initially. So like doing B or like U for underline is a good way to test a website without like potentially breaking it, because just underlining text isn't really going to break anything. So notice here, that worked as well. But now let's actually inject some JavaScript. So we'll do here script, and then in the script tab, we're going to do alert, and then just the word hello. And then /script, just to end it. And then we run it, and notice here we get a pop-up that says hello. And then it worked. And then we get the flag here, which is this guy here. And then we can just throw that into there. So any questions on reflected XSS and sort of why it's different from stored? Okay, cool. So the next one is on the same page, craft a reflected access payload that will cause a pop-up with your machine's IP address. So this basically just requires a bit of Googling. So we want to do the same thing with like script alert, but instead of hello, we want to pop up the IP address of the victim that's visiting the website. So we want to basically see JavaScript get IP of user, I guess. Or maybe let's try to get host name, because usually that's just the same thing. User. Not computer name. Let's see. JavaScript get IP of client. Let's see, client. No, that's too much. I don't want that. I want like this is where Googling comes in handy. JavaScript document get IP get hostname. Okay, location hostname. Returns the hostname of the current URL. Let's see that. Let's try location.hostname. I'm not sure if that's right, but we'll give it a go. Doesn't hurt to test. So instead of hello, we're going to do location.hostname. And we get an IP, but I think it's the IP of the website, not our IP address. So that didn't work. So hostname is the right parameter, but not looking for location. Let's see what other host names there are. Let's see. Location, host name. Let's see. So JavaScript host name of client. IP MAC address. Yeah, see, this is not what we're looking for because it's just too much stuff here. We're trying to look for. Let's go back to W3 schools because they had some good references here. Is there a search bar here? Okay, there is. Let's do a search for JavaScript hostname. Location hostname, which we saw already. If anyone else can find it before me, feel free to put it in the chat. Let's try window location. Window.location hostname. I feel like that's just the same thing. Yeah, this is the same thing we already saw. I'm looking for. All right, is there a hostname in document? Document.bcdefg. No. Okay. Element, location, navigator style window. Okay, well, actually, there's a window one. Okay, no, but no hosting there. Screen navigator location. Element. do a search here for host name. Window. Okay, let's try window.location.hostname. Let's give that a shot. Says location.hostname. We're gonna do window.location.hostname. That still returns that one. Oh wait, okay. I guess that was the right one. So it's window.location.hostname. Was the right one, and see we get the flag here. So that's the flag for that guy. Okay, cool. So yeah, it took a bit of Googling. That happens. That's a lot of when it comes to doing any sort of pen testing or hacking on a website, it's probably gonna be a lot of Googling for new things that you found and how to hack into it essentially, or how to find the vulnerabilities and how to exploit those vulnerabilities. It's gonna require a lot of research and a lot of Googling. But are there any questions on what I just did or reflective XSS in general before we go into the stored XSS challenge? Okay, cool. So let's go here. In the same site, we're gonna go to stored XSS tab, which is here. Yeah, no problem, Jason. See you next week. So for the stored one, it requires us to make an account. So I'm just gonna use a name called John, password, blah, whatever, it doesn't matter. Okay, cool. So now we're here. Now we go back to stored XSS, and here now we see we have a comment thing here. So we can add comments. If I do, hey, comment, it shows up here, hey. If I do, what's up, it's gonna show up there, right? So this is what stored is, because like if you notice here, if I leave, if I go like here and then I go back to stored, it's there because it's a stored XSS because it's being stored on this website's database. And this is what stored XSS is. Basically, if we're able to inject into this, then it's being stored on the website and not in the URL bar like it would be with reflected. So again, let's do a simple test like I was doing before, using just bold tabs, just so we don't, again, it's a good thing to do to make sure you're not, potentially messing up the entire website. So if we do B test, comment that, boom, you can see there it's in bold. So we have something here. And that was actually the first challenge, actually. Add a comments, you can insert your own HTML. And we did, and we got the first flag for the first question, which is right here. So that's that one. Are there any questions about, I guess, the difference between stored and reflected? Okay, if not, then we're gonna do the same thing. On the same page, create an alert pop-up box to appear on the page with your document cookies. So this time we're gonna be doing, again, like script alert, but instead of doing, like hello or document.location like we were doing before, we're gonna alert the cookies of this user. So in this case, again, we'll do some Googling here, JavaScript. Let's do get cookies. JavaScript cookies. Let's see if that. All right, so it looks like document.cookie is the name that we're looking for. So we'll go back here, do script alert document.cookie /script. And we're going to comment it. And then boom, you can see here, this is the cookie, which is connect.scd is the key. And the value is this whole thing here. So we successfully were able to output the cookie. Now, this is just sort of to show the potential harm it can do. A malicious actor, what they would do, instead of alerting, making a pop-up box that shows the user's cookie, that's kind of useless, right? Because imagine if like you visit this website and all of a sudden you just see a pop-up box with your cookie on it. That doesn't really matter. Like, who cares? A malicious actor, what they would do, instead of showing a pop-up box, they would actually send this cookie to their malicious server, right? And then once they have that, once they've taken your malicious cookie, they can basically set that as their own cookie and then log in as you. That's essentially what the potential harm is. So like, if you think about like why cookies are important, or like why if you're like trying to hack a website, if you can get the cookie, it's a good thing, is because if you have the cookie, you can impersonate the user. Having a cookie is basically just as good as having a username and password, because you have their cookie, you can just basically set it as your own cookie, and then you have access to the website as if you were that user. So the reason why we did a pop-up box here was just to demonstrate that we were able to get the cookie. But usually instead of doing a pop-up box, you would send it to your malicious server that you have running, and then you have the cookie just like that. And if we do OK here, we have now the flag for that question here, which is this guy right there. Okay, cool. Any questions on that part? Okay, so if not, then we're going to go ahead and do the next question here, which I think is the last one. Yeah, last one. So change XSS Playground to I am a hacker by using JavaScript. So here they're talking about this text here, XSS Playground. We want to change that to the words I am a hacker. So this is going to require looking into a bit of the source code of this website. So if I right click on a website and do view page source, I can see then the source code, the HTML source code of this website. And then we're going to look for XSS Playground. So Control F, XSS, or XSS Playground. Okay, you can see here we have 3 instances of the word. The first one is in the title, and that's up here in this guy. They're not asking us to change that. They're asking us to change this, not this. They're asking us to change this. So that's not the one. The next one is this guy here, which I'm pretty sure is this guy. So that's probably the one we're going to want to change, but let's just check the last one. The last one is just in the actual instructions, which is right here. And they don't want to change that one. They don't care about that. We want to change this guy here. So we're trying to change this guy. This is what we're trying to change to I am a hacker. So one way, this is basically just require just some knowledge of JavaScript. So if we actually open up the inspect element and then go to the console here, we can access this specific text if we do get element, or sorry, document.get element. Am I typing that right? Oh wait, sorry, I'm in the filter here. Sorry, you have to be in this guy. Document.get element by ID, and then we're going to put in the ID for this guy. And the ID, you can notice, is between span is right here, THM-title. So if we here do THM-title, you see it's even highlighting it for us because it knows it found it, XSS Playground. Now there's a couple of we can't just do this. We can't just do hey, because that's gonna give us an error. Because we can't just do like, I am a hacker, because it's gonna give us an error here saying no, because you can't assign a string to an object type. We're trying to access the specific property value of this. So if we do dot here, we can see the list of all the properties this guy has. Now there's 2 main ones that we care about, and 2 potential ones that this string here will be stored in. One would be value. So if we just output that, or maybe it's value of dot. Wait, is it just dot value? I thought. Okay, maybe it's not value. Maybe value doesn't work. Okay, so value doesn't work for this one, but value is another one that could be useful. But the other one that we really care about is inner HTML. Or I guess inner HTML and inner text are the 2 that we care about. So if we do inner text here, we can notice here it's XSS Playground. If we do inner HTML, also XSS Playground. So these are the values that we want to change in order to change this to our string. But we want to do it all in here, right? We don't want to do it in the console because that's not really changing anything. You're just changing stuff on your local website, not on the actual the back end of this web server. So what we're going to do here, we're going to inject our JavaScript with script, and then we're going to do document.get element by ID, just like we had there, and we're going to look for the ID THM-title, and then we're going to do .inner HTML, right? And then we're going to set it equal to. Now we're going to change it to I am a hacker, and then don't forget your semicolon to end it. and then we're going to close the tab to the script. So basically doing what we were looking at here, but we're actually going to send it to the comments so it gets stored on their website. So we're doing get element by ID to HTML title to get this whole object. Then we're getting the inner HTML, which is specifically just the text, and we're changing it to this here. So then if we do comment, again, it's just going to pop up the alert from the other cookie here, which is fine. And then look, notice here it says I am a hacker, and it worked because we were able to change it successfully with injecting our JavaScript. So if I were to even go away and then go back to stored, notice how it still is changed because it's stored on the website. We've permanently defaced this website with our XSS. And then you can see here, we got the flag, which is right there. And then we can just throw it right into here. So does anyone have any questions on cross-site scripting in general? Any of these specific challenges that they ask you to do? Was anyone stuck on a certain part and I can help you through it? Or any questions related to any of the things we talked about, injection, broken auth, or XSS?
If you want to check if command injection works, do you just type in a command and see what happens?
Yeah, so for command injection, it's a little tricky because specifically for command injection, like what we were doing before, 99% of the time, it's not going to be as easy as what we were doing before. Because before, we just typed in a command and it just worked. A lot of the times, you're going to have to do some escaping. So I can give you an example here. Let's just pretend here. Let me close this real quick. All right, let's pretend that this comment section here isn't vulnerable to XSS, but it's vulnerable to command injection. So if I were to type in who am I? Let's say after we go through all this, let's say this doesn't work though, right? You're checking for command injection, you type in who am I, but it just prints out who am I, not the actual results. So sometimes you have to escape out of the parameters that they set for you to actually use a command. So one example would be putting a single quote and then putting who am I. What this will do is that if this who am I is, or any of this text here is being put in between single quotes, if you put an extra one like you have here, it's going to end the single quote, and then anything after it can be interpreted as an actual command. So that's one example. So doing who am I, and let's say then in our made up example, that would instead of saying who am I, it would actually output the command, the actual result of the command. So that's a lot of time. It's not just as simple as just typing the command. Most of the time you have to break out of the whatever sort of double quotes or single quotes or whatever you're inside in order to actually get command injection. Does that make sense?
Yeah, that does. Thank you. So it's kind of like you just see what works, basically, right?
Yes. Yeah. 99% of the time of when it comes to web hacking, you're really just trying a bunch of different things and you're looking for weird behavior. If you can find weird behavior, then you really start to dig into it, and then you can find vulnerabilities from it. That's the main thing. But at first, you're just trying a bunch of things.
Okay. Thank you.
Yeah, no problem. Okay, cool. Any other questions?
How would you protect your website against these attacks?
Yeah, so with injection and XSS, to protect your website against it is really just escaping. So what escaping means is you're not allowing any special characters to be interpreted as the actual way that a malicious actor would intend to. So for example, with injecting cross-site scripting, doing something like this should never be allowed. You should not, this here, these brackets, it should escape those. It shouldn't interpret them as JavaScript. And what that does, if you URL encode it, or HTML encode it, sorry. So if I do HTML encode online, if I put in angle bracket script, notice how it doesn't output angle bracket, it outputs this, the word script, and then this. This is called HTML encoding. Let me fix that. So when you're HTML encoding, you're basically escaping these special characters. So it's impossible for them to be interpreted as actual JavaScript because it looks like this. That's essentially what you're trying to do to prevent cross-site scripting. If you're able to HTML encode any sort of special characters, then you're essentially protected from 99% of cross-site scripting. As the same
Gotcha.
for most types of injection as well.
All right, sweet.
Cool. So any other questions? Can you inject PHP to execute commands? You can. You absolutely can. So PHP is another type of injection as well. It really depends. Most of the time, injecting PHP itself is not super common, but uploading files, PHP files, and then that run malicious code, and then that gets uploaded to the web server, that's way more common. So like if let's say you have a website that like allows you to upload like images, for example, for like your blog or something, but instead of uploading a PNG, you upload a PHP script, the .php file. If they are not properly sanitizing their files, then that PHP can get run on that server, and then you can get like complete command execution on that web server. So yeah, injecting PHP is possible. It's just more likely it's going to be injected through file uploads rather than like in actual text. Okay, so let's go. Awesome. So that was the end of the meeting. Thank you guys for coming. For future meetings, next week, I'm thinking I might do a presentation on malicious Vba macros. For those who don't know what that is, it's like a lot of like Word documents and Excel documents and stuff allow you to have something called macros, which makes your like, it might make your job easier and stuff, like for automating certain things, but it can also like, you can have malicious macros that like will download or inject like malware into your computer essentially. And so I'm thinking I'll probably do a presentation on that next week, because like malicious Vba macros are like probably the most common way that both like real world hackers get into massive companies, and also like how red teamers will do campaigns and engagements on their companies. So it's like one of the most common ways that massive like nation state attacks even will get in, is just through like malicious Vba macro. So I'll probably do a presentation on that next week if you guys are interested in that. Again, to restate, if there's any other topics that you want to learn about or want to potentially present on, put it in that Google Doc, and then reach out to me if you're looking to potentially present one on your own. That'd be really cool if you guys can like, maybe spend a couple weeks or however long learning about a topic you enjoy, and then presenting it just for like, maybe doesn't have to be super long, like even just 30 minutes to an hour or whatever with a quick exercise would be really cool. So reach out to me if you're interested in doing that. And yeah, other than that, have a great rest of the week, and I'll see you guys on Tuesday.
Thanks for putting this together.
Yeah, no problem. And I'll stick around for a few minutes in case anyone has any other questions.
All right, I got to bounce, but I'll see you next week.
All right, see you later.
Can you like circumvent character escaping to do that to cross-site script or no?
So you can't circumvent HTML encoding. That's not possible to circumvent, at least as no one has been able to so far. But some people will implement their own forms of escaping. And a lot of the times they'll do it incorrectly, and those ones can be bypassed. And that's like, you would think that it's not super common, but weirdly enough, a lot of web developers will try to implement their own way of escaping characters. And you'll see that a lot on web apps, and they just won't do it correctly. And so it's still vulnerable to XSS. It just requires a little bit of work to like escape that. So yeah, not HTML encoding specifically, but yeah, it is possible.
Okay. Thank you later.
Yeah.